Hello and welcome back to the Leukopak Lady. Today we're diving into a topic that is closely tied to the first mile of cell and gene therapy: how collection and transportation of starting materials impact the choice between centralized and decentralized manufacturing models. Whether it's shipping cells across the globe or handling them in a local hospital clean room, the way materials move sets the stage for everything that follows. First, let's step back a little and define the key manufacturing models. Centralized manufacturing is where all production takes place at one or a few large sites. These sites are often located in big metropolitan areas with rich scientific talent, frequently near the original university where the therapy was developed. This setup allows for concentration of resources, specialized equipment, and experienced staff. However, in this model, starting materials need to be shipped to the central site from across the country or even internationally. This adds complexity to the first mile because every material shipment must be carefully coordinated, ensuring it arrives in optimal condition and on time. Decentralized manufacturing takes place closer to the patient, often in hospital-based clean rooms or regional hubs. In this model, multiple manufacturing sites may be set up in different locations, far from the original development site and sometimes even far from where the starting materials are collected. The goal is to bring manufacturing closer to the patient so that the last mile, or the delivery of the therapy, goes as smoothly and efficiently as possible. In terms of the first mile, though, this approach can reduce some logistical risks. For example, starting materials don't have to be transported across vast distances. The collection site and the manufacturing site are often much closer together, making shipping more manageable. It also helps mitigate potential delays that could happen when dealing with long distances or international shipping. So now that we've defined these two models, let's explore how the first mile, or the collection and shipping of the starting materials, can directly influence which model is best for a particular therapy. In the centralized model, shipping starting materials over long distances presents a few challenges. Time sensitivity. If the materials are delayed in transit, there's a risk they could lose viability before they even reach the manufacturing facility. This is especially crucial for patient-derived materials. So the first mile of transportation is critical here. Every hour matters. Cold chain and storage risks. Starting materials need to be stored at very specific temperatures. As they travel over long distances, starting materials face higher risk of temperature excursions that can compromise quality. In the decentralized model, the closer proximity to the collection and manufacturing site addresses some of these challenges. Reduced shipping time. Materials are transported for shorter distances, which lowers the risk of delays and increases the likelihood that cells will remain viable. Reduced handling complexity. Less handling reduces the chance of contamination or degradation during transport. However, there are still challenges. Even in a decentralized system, you need to ensure that the collection process is standardized, that the right conditions are maintained during transport, and that the quality of the material remains high before it is processed. So while centralized manufacturing may offer economies of scale, the distance and complexity of the first mile can increase the risk of delays and product degradation. On the other hand, decentralized manufacturing reduces some of these risks, but can bring its own set of logistical challenges, especially when scaling up to meet demand. Next time on the Leukopak Lady, we'll dive deeper into the trade-offs between these two models and look at real-world examples to see which might be better suited for different types of therapies. Stay tuned to see how these challenges play out in practice.